Hello and welcome back to part 5. So the first thing we want to do is go back to Tetris player and the spawn location component. We want to set it to be hidden in game. We don't need it to be rendered. So compile, save, go back. Now before we actually line this up within the grid and set the default values, we actually need to make a debugging tool. We're going to make a debugging tool to help us out, and it'll also help us if there are any problems. We can get right down to it and fix it. You don't have to do this, but I do strongly recommend you do it. It's nothing too crazy to make. All we're going to do is we're going to create an array the same as in the Tetris player, but it's every time there's a block in a certain part in the grid, we're going to have a red sprite show up there so you know that it's in the correct position and everything. You'll see what I mean when I make it. So let's go ahead back to the game folder, select new blueprint class, actor, and we're going to call it debug tool. So after you've opened the new debugging tool, go ahead and search for a sprite, paper sprite, and I'm going to name it root. I always name the scene root root. So we'll make a function called create grid data. What we need is 2 for loops. And for the first index, we're going to set it to be 21, or the last index on the first node. We're going to set it to be 21, and the next one, we're going to set the last index on the second node to be 9. And I'm going to comment this as call and row. So that way we can keep this nice and clean. Let's go ahead and promote these to local variables. So we'll just call it call underscore L. Then we need row underscore L. So now what we're going to do is we're going to place this into the world. And before I do that, let's go ahead and assign the sprites. I'm going to make it the green one. And also I'm going to set this to be hidden in game as well. And when we're done with our project, we can go ahead and delete this from the scene. But right now, we'll take it and line it up right here. It's very important that you line this up exactly above the grid. So here's the location if you want to perfectly line it up how I have it in the project. So let's go ahead and get the world location of the root, and let's split it, and on the x-axis, let's add the row that we're currently on times 32. So like I mentioned in a couple videos ago, that if you're using different artwork, you plug in the size here. But since this is 32 by 32, everything is 32 by 32, we're going to leave it at 32. Go ahead and copy and paste this. And this time, we're going to set it on the Z. And we'll switch out row with column. Then we're going to look for a make vector. We'll plug X into X and Z into Z. So we're going to go ahead and use an add node and add 0.1 to Y. So we're doing that so when we spawn in sprites, it'll be drawn on top of everything else. You could use the translucency sort, but for this one, since it's not going to be in the main game, I'm just going to add 0.1 to Y. We're also going to spawn in a text renderer, so that way we know what row and column we're on. You'll see what I mean when I finish it. So let's go ahead and promote this to be a local variable. We'll just call it loc for location underscore L. So let's go ahead and make a variable called show block, and we'll put a branch on this. This will be defaulted to false. Now on the false condition, let's look for add text renderer component. And let's set horizontal alignment to center and vertical alignment to text center, and set the world size to be 0.8. And then let's go ahead and promote this to a variable as well. I'm just going to call it text, and this needs to be an array because we're going to keep track of everything that's been created, so that way we can destroy it or use it later on. So let's go ahead and make that into an array, and we'll look for the add. Off the return value, let's look for set world location and plug that in. And the location is going to be the local location variable that we made. Now let's drag off the return value one more time and look for set text. And now from the value, we're going to look for format text. We're taking the row and the column and we're going to put it inside this text. So that way it'll show up on here and we can quickly figure out a position and everything. We can test some things out if we need to. And we'll be able to line this up and set the grid data values on it. So with your format text, you should have something with I, R, and C for index, row, and column. Go ahead and press enter and these extra pins will show up. So for column, let's plug in column. And for row, we'll plug in row. Now for index, we need to make one more local variable, call it index, and make sure it's an integer and not an array. And go ahead and plug that in as well. Now let's go back over here and let's take the index and we're going to look for ++ or increment int and we'll plug that in. Now you need to set the default value to be -1 for this to work. So make sure you do that. And now that we've done that, let's go to the true branch and look for add paper sprite. And this time you need to set it to be the WP sprite or the white sprite. Now go ahead and promote this to be a variable as well and make sure it's not a local variable. Same thing with text. It needs to be in the main variables tab. And after you've done that, this needs to be set to an array. And once again, we'll use the add array. So from the return value, let's go ahead and look for a set world location and plug in the location as well. We'll compile and save. So before we add this into the construction script so we can get this to run, let's add one more function called remove grid data. Now when we come here, so in remove grid data, let's take the text and get the length and we'll look for greater than 0. So if this is empty, do nothing. And let's go ahead and put that on a sequence because we're also going to check the block or the sprites array as well. So if the length is 0, then do nothing. But if it's not, let's take out the text and look for and use a for each loop. And we're going to look for destroy component. And then after we've done that, we need to clear out the array. That's very important and make sure you put that on the completed. Now we can go ahead and copy this. Control-C, Control-V, and we'll plug it in here. And we're just going to drag the sprites variable onto the text. And for the for loop, you're going to have to disconnect everything, but we can just plug in the sprites into it and then plug in the array element. So far we're done with this function. Now let's go to the construction script and add a branch. And we'll default it to true for right now. And we'll call it show debug text. And make sure it's defaulted to true. Actually, we're not going to use the construction script. Go back to each function and click on call an editor. And go ahead and compile and save. We need to go back to the create grid data and look for the text renderer and set the rotation on the z-axis to be 90. So after this, if you press compile and go out to the editor and select create grid data, it's going to be populated. It's going to go up. It's not going down, and I honestly do not know why it does this, but if we go back and create, so if we take the row and we get an addition node and on input A we put -144, and then on the column we'll put 368 and we subtract it and we use that instead, and we compile and we press create grid again. Now everything will be populated correctly. I'm not really sure what I'm doing wrong here. If my math is just off or something. But so now if we look out into the editor, you can see what I was talking about when I said how we're going to populate the array. So I is for index and row is what row we're on. So row 0, 1, 2, 3, and so on. And then we have column 0. Now remember, column 0, it's only going to be used for a game over check. If a block is at column 0, that means it's too high and we need to call a game over. And you can also see the columns going down. And like I said in the previous video, I might have the row and column backwards. If I do, I apologize, but I always think of it as in how a computer renders an image to the screen. It goes from left to right, and then it goes down one, and then left to right. So that's kind of how I populated the row and column, but again, I could be wrong about that. We need to go to the construction script and create another variable called show debug, and we're going to change this to be a boolean and not an array. Let's go ahead and select instance editable so that way it'll show up in the editor. And I'll go ahead and plug this in, and we'll default it to true. And so if this is true, we're going to use the show debug text. We're going to set that to false, and then we're going to call create grid data. So if we go back to the editor, we have show debug text. We can turn that off and everything will disappear. And if we click it again, everything will be shown. So if we go back really quickly, instead of show block, we should actually be using show debug text. And we'll plug that in. And now, so that way we don't have to switch around the true and false conditions. Let's go ahead and just use a not. Now if we go back to the construction script, now you're going to see all these white blocks. Okay, I apologize. The editor crashed on me, so I'm not sure where I left off at, but we'll go ahead and pull this out and add a branch to it. And if this is true, we want to create grid data. However, we don't want to plug this in just yet, otherwise it might crash on you. Create grid data, and instead of show block, we don't even need that variable anymore. We can just delete it. We need show debug text, and let's use a not boolean on it. And before we plug it in, let's disconnect this and make sure you compile so that way it doesn't crash on you. So go to add paper sprite component and look for translucency sort, and we want this to be a high value so that way it gets drawn on top of everything else. And also let's go ahead and set the collision to be no collision. And now we can go ahead and plug this in. And we'll go back to the construction script. Actually, this is wrong. We actually need another variable, promote to variable, and we're going to call it show debug. And we'll leave it at false for the moment. So let's go ahead and we'll make a branch, and we'll have show debug. We'll make that as a variable, set it to be instance editable, and same thing with show debug text. And then we'll run the create data. But if we're not creating data, let's go ahead and remove it. And we'll compile. And now when we go out to the viewport, if you set show debug text to true and show debug, you'll get the text. So that way we can easily find so we can easily set the default values on the blocks. And then if you do turn off show debug text, these sprites will show up, and we're going to use those later on. So let's go ahead and set show debug to false, and let's go ahead and disconnect the construction script one more time. I forgot a step. If we go to create grid data, when we go to sprite, we need to set the alpha on it to be 0.1, so it's just barely visible. We'll plug that back in. We'll come back out and we'll hit show debug, and there you go. You can see it on the grid, and like I said, so it'll show up. And when we place a block, where the block is placed at, all those sprites are going to be set to red. So that way we know, we can definitely double check and make sure there's no bugs, everything is being placed in the right spot. So now that we've done that, let's go ahead and go back to the block base and go to location offset and set it to be -16 and 16. And after you've done that, go to block data and go ahead and set your point on all of the pieces, A, B, C, and D, to be what I have on the screen. I already went through and figured out all these numbers. So after you've done that, if you press play, and now you can move the block to the left and to the right, and it stays in the grid and it won't go out of bounds. Okay, so now that we have that taken care of, let's go ahead and go back to the Tetris player. And now when we do update fall, we'll go back there and we'll go ahead and remove this for right now. So now what we want to do is every time this is called, we want to move the block down 1. Well, first we want to check it to make sure there isn't any other block there and it's not the floor. And if there's not, we'll move it down 1. So we'll get the current block, and we'll go ahead and call the function we made called grid data as array, and we'll run a for each loop on it. And then we're going to call the previous function we made, which was update point, which we should actually rename that to be something else, but we'll leave that for right now. We want to take the column and we want to subtract it by 1. And then we want to go ahead and break this and hide everything but point. So now we're going to go ahead and get the place filled function, and we're going to plug that in. And actually it shouldn't be -1, it should actually be +1 because we're going down and we're adding. So now let's go ahead and do a switch statement. So before we continue this, let's go ahead and make a new function called lock block. And for right now, we're going to leave it blank. We're not going to do anything, but we'll have it there for later. And we'll go back to the event graph and we're going to add a custom event. And we're going to call it prepare next block. So we'll go back to update fall. And so if it goes down 1 and the spot is empty, we don't do anything. We go ahead and we allow it. But if the block is taken or on the floor, we need to go ahead and call lock block and add a return node. But if it's not, so if all 4 pieces don't collide with another block or go past the floor, we'll take the current block and we'll call the function push block down, and by 1 step. We want to leave that as default. And we'll go ahead and return. So if we go back and play the game, you'll see that the block will keep falling until it hits the floor and then it will stop. We're going to go back to the lock block function. What we need to do first of all is set allow input to be false. So we'll get the current block and we'll look for grid data as array. We'll do another for each loop on it, and we'll break this and we'll break the point. So we'll get the grid data and we'll call set array element. Now we need to give this an index, and we're going to set the item to be true. But we need to go ahead and call the function get position to index. We'll plug that in for the point, and we'll set it to be true. So now that we've done that, nothing is going to change. So what we want to do really quickly is we want to create a event dispatcher, and we're going to make an event dispatcher that's going to call an event on the debug tool that we made. So let's go ahead and create an event dispatcher, and we're going to call it update grid. And we're going to pull that out, we'll call it, and we'll go ahead and plug that in on completed. So now we'll go back to the debug tool, and we'll go back to event begin play, and we'll get the show debug. We'll plug this in. We're going to bind to the Tetris player. So you want to have this condition, so that way if we don't need the debugging tool, it won't bind to the Tetris player. So let's go ahead and make a new variable, and we'll call it Tetris player. And we're going to change that to be a Tetris player object reference. We'll set it to be instance editable, and we'll compile. And we'll take this and we'll do an is valid. And if it is valid, we want to take it. From the Tetris player, we want to look for assign update grid. So it'll go ahead and give us a new custom event. We won't have to create another one. So plug this into is valid. And every time this is called, we want to get the Tetris player and get the grid data and do a for each loop on it. And we'll connect a branch. And now if that spot is not filled, we'll get the sprites that we have. We'll use a get. We'll plug in array index to the get index. And we want to set sprite color So we'll set everything to be 0. So it won't even show up. We won't see anything. But now in the true condition, if that spot is filled, so we want to take the get index once again and plug it in as the target, and we'll set the new color to be red and the alpha to be 0.1. And we'll go ahead and compile and save. Now, if this is true, show debug, we also want to set show text to be false. And then we want to call the create grid data. But before we call that, we actually want to remove it just in case it's currently in the scene, so we won't add any more. So go back to the debug tool, and from the Tetris player, drop down, go ahead and select Tetris player. And we'll go ahead and press play. And now when it falls and hits the floor, you'll see all the white sprites will disappear because their alpha is being set to 0. And then you'll notice that there are red sprites in front of the block that is in the grid. And so now that we know that everything is working, there aren't any bugs so far, we can go ahead. And one other thing that we should do is we'll go to blocks, we'll create a new graph and call it animation. And let's create another variable and we'll call it locked. It'll be a boolean. And so let's make it a custom event and we'll call it play lock anim. And what we're going to do is we're going to set locked to be true, and then we need to go ahead and get pieces as array and do another for each loop on it. So we'll call set sprite. And now we're going to pick a sprite as the animation, and you'll see what I mean in a minute. But well, for right now, we'll use the white sprite, but you can use the gray one if you'd like, but I'm going to use the white one. So now we're going to use a delay, and we'll leave it at 0.2 for right now. So after the delay, we're going to have to copy this again. So just Control-C, Control-V. We'll plug it in over here. And now for the sprite, we want to set it back to be the default sprite that we have. So now if we go back to the Tetris player, and when we call lock block, before we do this, we can take the current block and call play lock animation. So we need to go back to the lock block and add a couple more nodes to it. So first thing is we're going to take a branch and we're going to look for game over and do a not game over. Then we need to get the fall timer that we made and call clear and invalidate. And then let's go back to the block base. And we're only going to call this animation once. So we're only going to do it if it's not locked. So now if you go back and play the game, you'll see the little animation and then everything on the grid will update. So we want to go back to the lock block function, and from the loop body, from grid data as array, we need to take the point and we want to check the column value. And we want to see if it is equal to 0. So if it doesn't equal 0, then we can go ahead and set the array element to be whatever the position is. But if it is 0, let's go back to the event graph and we'll add one more custom event. And we'll call the custom event call game over. We already have another variable called game over, so we have to put call game over. So we're going to go ahead and add a print string that just says game over, so that way we can make sure this is working. So we'll go back to lock block, and if one of the columns on any piece is 0, we want to call game over. So we'll call that function, and then we'll go ahead and set game over. Actually, we'll set game over first, set game over to be true, and then set allow input to be false. So from the true branch, if any one of the pieces is 0, we're going to set game over to be true, set allow input to false, and call game over. And then we'll add a return node. So after lock block is called, let's go ahead and call the prepare next block. And then from prepare next block, let's add a delay to it, so that way that animation can play out. So add a delay, and we'll set it to be 0.1, and And let's go ahead and promote this to a variable. And we're going to name it animation time. And we'll compile. And after that's completed, we will call. So after the delay, we'll go ahead and add another block. But before we do that, let's go back to the block face and go to the animation tab. And with this delay node, we're going to get the Tetris game. We want to get the animation timer, and we want to use that as the time. So we'll go ahead and compile and save. And let's go back, and we're going to cut this out, and we're going to go into the add block function. And we're going to paste that in here. And what we should do is go ahead and promote this to be a variable, and we'll call it fall speed. So before we test it, I'm going to set the fall speed to be 0.1, so that way it will fall a little bit quicker. And we'll press play, and it'll fall down, and it'll lock, and another block will fall down, and they will start stacking. And you can press left or right to put this in any position. And now you have the building blocks of a Tetris game. Though there still is a lot more we need to add. I'm going to set that back to 0.5. So there's still a lot more to add, but we have a lot done so far. And I'm going to go ahead and end the video here. But before I do that, I would like to mention I have a Patreon that you can check out if you'd like to support me. I'll put a link to it in the description. So thank you so much for watching, and I'll see you in the next video.